In this video, we want to solve for solutions on the interval from 0 to 2 pi. So we're looking at radian solutions rather than degrees. You can solve the equation or equations in terms of degrees, and then if you're more comfortable working in degrees, you can do that. There's two equations here. That's number 1, number 2. So let's look at the first one. We want to solve sine squared theta equal to 2 cosine theta plus 2. Now it's always easier to solve a trig equation if you only have one type of trig function. Here we have a sine, we also have a cosine. So we try to use some identities to try to make the conversion to one function, if possible. So in this case, I'm going to use a basic trig identity right here. Cosine squared of an angle plus sine squared of the same angle always equals to 1. So that means I can solve either one of these for either cosine squared or sine squared. Here I solve for sine squared. Sine squared theta should equal to, take the cosine squared over, 1 minus cosine squared theta. So we're making the substitution then. So sine squared, we replace sine squared by 1 minus cosine squared theta. Leave the right side the way it is. There we are. So we make the substitution for sine squared theta using that basic fundamental identity. And what we have now is a quadratic in the function cosine theta. So taking everything on the right side over to the left side, that will change the sign. So the left side will stay 0. And then we get a positive cosine squared theta, and then everything else stays the same on the right side. I have a 2 cosine theta, and this is not a square here, that's just cosine. And the 1 comes over, becomes a minus 1, so 2 and minus 1 is 1. And just look at this like a quadratic in cosine. Just like this were x squared plus 2x minus plus 1, I should say here. So plus 1. Subtract 1 here too. So the right side factors in into cosine of theta plus 1. And cosine of theta plus 1. Or I can just write it cosine of theta plus 1 under the square root. Take the square root of both sides, plus or minus, and the left side, that's plus or minus 0, still going to be 0. And then square root of this one, using the cosine of theta. If you want to leave it as two factors, you can. You can leave it as cosine theta plus 1 times cosine theta plus 1. You set each factor equal to 0, you get the same thing. You gotta get a repeated solution, but I try to solve this with cosine, add negative 1 to both sides, I get negative 1. Cancels on this side, so I get cosine of theta equals to negative 1. So then you can solve this for theta. Using your calculator, or this is a quadrantal angle, so you should know the answer to this one. It's 180. The cosine of 180, or the same thing as pi, is negative 1. Since we want the answer in terms of pi, I do this as theta equal to pi. If they wanted in degrees, you could write out 180 degrees. That's your solution to that one. And go to the next one. Got tangent of theta is equal to cotangent of theta. Again, we have different functions. Easier to solve if we have just one function in the equation. So one way we can do that here Let's just multiply through by, I'm going to multiply through by tangent theta. Both sides. So multiplying the left side by tangent of theta, that'll just give me tangent squared of theta equals to 1. Because cotangent and tangent are reciprocals. So when I multiply the cotangent by tangent, I get 1. This is like multiplying x times 1 over x. That's the same thing here. Cotangent theta is 1 over tangent, so the tangents cancel out, I get 1. Then this is like if I had x squared equal to 1, I would take the square root and get x is equal to plus or minus 1. In this case, instead of x, I have tangent of theta. So one equation would be tangent of theta would be 1, or tangent of theta would be negative. And we solve these individually. So we're looking for an angle whose tangent then is equal to 1. If you know your 45 right triangle, this angle is 45, and this angle is 45, and this is 90 degrees here. Then the tangent of this angle here, which is 45, is 1 over 1, which is 1. So the picture is. So I know right away that one angle in the interval from 0 to 2 pi is 45 degrees. But remember, we're looking for radians. So what is 45 degrees in terms of radians? Just multiply that by pi over 180 and reduce it. You'll get pi over 4. So that's one answer for this equation. In this uses 45 or pi over 4 is a reference angle. So where can we put the reference angles? Here. We can put it over here in quadrant 2. We can go in quadrant 3, quadrant 4. But we're looking for an angle whose tangent is a positive value. So that means, remember, the tangent function is defined by the y value over the x value. So the xy is a point on the terminal side. So in this quadrant 1, both x and y are positive. In quadrant 2, the x is negative, the y is positive. Quadrant 3, they're both negative, so it's negative, negative. Quadrant 4, the x is negative, we go down, so the y is, the y is positive, because we go to the right, and the x is negative. So I should say the y is negative. So to the right and then down, so plus minus. So we want the quadrant where the tangent is positive. Well, positive or negative in quadrant 2 is not going to work. In quadrant 3, negative or positive still give you a negative. So in quadrant 3, the y is negative, and the x is negative, and minus y will minus 1. So the angle we want is right there. So if I put my reference angle right there, this is 45, and then this angle here would be 180 over, or 180 plus the reference angle, which is 45. That's 225. And 225 in radians, multiply that by pi over 180, it's 5 pi over 4. Now for this one, tangent of theta is equal to negative 1. So now we want opposite signs on the coordinates, because we want it to come out negative. So the opposite sides are going to happen in quadrant 2 and quadrant 4. So if my reference angle is this one right here, then that angle right there would be 180 minus 45. So that's equal to 135, or the same thing as 3 pi over 4. And now we want a second one. Do we have a second one? Yes, in quadrant 4, I have a positive x and a negative y. So negative over positive is a negative. So that means this is my reference angle. This angle right here is 45. And the angle that I want the center position would be 360 minus the 45. So that would give us an angle of 315 degrees. If you convert that to radians, that's 11 pi over 4. So normally we would the answer in sequential order here, so theta then our solution could be pi over 4, 3 pi over 4, 5 pi over 4, and 11 pi. Over 4. Very nice. So thanks for watching. See you next time.